Hello, this is question 5 on your June 2018 Statistics and Mechanics paper from Edexcel. And you have the lifetime L hours of a battery has a normal distribution with mean 18, standard deviation 4. Alice's calculator requires 4 batteries and will stop working when any one battery reaches the end of its lifetime. Find the probability that a random selected battery will last for longer than 16 hours. So if we have our variable L, which is the lifetime in hours and is a normal 18 for squared, we just want to find the probability that L is greater than 16. They want us to find the probability of L, the battery lasting longer than 16 hours. We are just going to use normal CD in the calculator. The lower limit is going to be 16 and then a large number. It should be at least 5 standard deviation for the mean, but I would just write a large number like 9999999. Yeah. Mean 18, and remember the standard deviation is 4, so I'm not writing the 4 square in the calculator, I'm writing the 4, the standard deviation, and then you get the value straight away, which is 0.69146. We can round 4 decimal places, for example, 0.6915. Yeah, probability. Then at the start of her exams, Alice put 4 new batteries in her calculator. She has used her calculator for 16 hours, but has another 4 hours of exams to sit. Find the probability that her calculator will not stop working for Alice's remaining exams. This is a bit hidden conditional probability. Yeah, so we are not just trying to find the probability that the calculator lasts, the batteries last for 16 plus 4, 20 hours, but we already know that the batteries have last 16 hours. Yeah, not all the batteries last 16 hours, only 69% of them. So that's why it's conditional probability, because we already have that information. So really we are trying to find the probability that the batteries last more than 20 hours, given that already they have lasted 16 hours. Yeah, because that's where they say that the batteries have been 16 hours already working. Yeah. This probability is the probability that lasts more than 20 hours and more than 16 hours at the same time. So it's really probability of L greater than 20. Yeah, remember, probability of A given B is probability of A intersection B divided probability of B. That's what I'm applying. Yeah, probability of both things happening is really the probability of L is greater than 20 divided by the probability of L greater than 16. I have this probability from this question. I'm going to do something very similar to find this probability with the calculator. So lower limit is 20, upper limit very high number, mean 18, standard deviation 4, and I get this value. And then I divide by the value that I got before. That was 0.69146. I would keep the values in the calculator, divide, and then round at the end. Yeah, so we have 0.44621, and I'm going to round again to 4 decimal places. So 0.4462. Yeah, so this is the second part. Then it says Alice only has 2 new batteries, so after the first 16 hours of her exams, although her calculator still is working, she randomly selects 2 of the batteries from her calculator and replaces these with the new 2 batteries. So that the probability that her calculator will not stop working for the remainder of the exams is 0.199 to 3 significant figures. So now she has 2 batteries that are new and 2 batteries that have been already working for 16 hours, and she wants to check if they are working 20 hours. So we have 2 batteries that are new. So we need the probability of those batteries lasting more than 4 hours because they are new. yeah? And I have 2 of those. So I'm going to multiply them together or square this one, yeah? Because I have 4 batteries. I want the probability of the first one lasting more than 4 hours and another lasting more than 4 hours. And so I'm going to be multiplying the probabilities. And the other 2 working at least 20 hours when they have worked 16 hours. So the old ones, the ones that have been 16 hours, I want to see if they last more than 20. And I found the probability. So I'm really doing the 0.44621 squared. Yeah. So 2 new batteries, 2 old batteries. Again, we find this with a calculator. This probability is quite large because 4 hours is not much for a new battery. And then this value here, and this is 0.19901, and they say show that is 0.19923 significant figures. So this is 0.19923 significant figures. Yeah. Then the last part is a hypothesis test. So it says after her exams, Alice believed that the lifetime of the batteries was more than 18 hours. She took a random sample of 20 of these batteries and found their mean lifetime was 19.2. Stating your hypothesis clearly and using 5% of significant level, test Alice's belief. So we so for C, no, D, no, D. She's checking 20 batteries, so N is 20. The observed value was 19.2, yeah. Significant level is 5%, so 19.2 hours. Significant level or level of significance is 5%. And she suspects that the lifetime was more than 18 hours, yeah? So it's a one-tail test. H0 is going to be that the mean is still 18, and H1 is going to be her belief that is more than 18 hours. Remember, if my variable, well, it was called L, no? Not X. L was N18 4 squared. That means that the mean of the time of the batteries, which is what we are checking here, is going to be distributed as a normal 18 4 squared but divided by 20. And be careful because this is the variance altogether, and I'm going to put the square root of this in the calculator. Yeah, so the standard deviation in the calculator is going to be 4, so square root of this one divided by the square root of this one. Yeah, you have to be careful because this is the variance, so the standard deviation is going to be 4 divided by root 20, and that's what I put in the calculator. Yeah. There are 2 ways of doing the hypothesis test. Remember, we can find the critical region, or we can find the probability of finding this value and comparing with the level of significance. So if I do critical region will be a value such as the probability of L, the mean, being greater than a certain value A is equal to the significant level. Yeah, we can use inverse normal to find this value of A, but you have to be careful with your parameters. Yeah, so you use inverse normal, the area is 0.05, this is the mean, this is the standard deviation, and then you find A. If you find A, you get 19.47, which means the critical region is the mean greater than 19.57. And then we compare with the observed value. So the observed value is 19.2, which is not greater than this one. Yeah, not greater, so it's not in the critical region. The observed value x 19.2 hours is not in critical region, which means, therefore, I don't have enough evidence to support her belief, so I have to accept H0. Yeah, there is not enough evidence. Accept H0. Not enough evidence, and you should write this sentence. evidence to support that the mean is greater than 18 is more than 18 hours, or her belief, yeah, if you want to do that. So this is method 1, using the critical region. The other way is checking the probability of L greater than the observed value is smaller than the significant level. So we find this value with the calculator. Again, be careful because this is your distribution. If you find this value, this is 0.0898, which is greater than the significant level, and if it's greater, there is not enough evidence to prove this one. Yeah, so the probability is still large enough to accept this one and not reject it. So accept 80, and again you should write this sentence, yeah, not enough evidence to support that the mean is more than 18. So really the conclusion is the same if you find the critical region or if you use this method. It doesn't matter which one you use. In some questions they will ask you to find the critical region, so you need to know how to find it regardless, yeah. And that's all with this question.